number one asks us to write an equation to represent the inverse of this function. Now, keep in mind, when you see f of x, that's really the same thing as y equals. So to find the inverse, the first thing you're going to do is you're going to switch the x and the y. So we're going to switch this y to an x. So I'm going to rewrite that as x equals, and I'm going to switch this x to a y. So it'll be 4/3 y minus 5/3. Okay, so now what we have to do is we just have to get the y all by itself in this equation. So I'm going to add 5/3 to both sides, leaving me with x plus 5/3 equals 4/3 y. And now we have to get rid of the 4/3 in front of the y. I mean, you could divide both sides by 4/3, but then you're going to have fractions within fractions over here. So an easier way is just to multiply both sides of the equation by the reciprocal of 4/3, by 3/4. Because what happens when you do that is the 4 on top cancels with the 4 on bottom, the 3 on top cancels with the 3 on bottom, and that leaves us with just y. And then here, just distribute the 3/4 in. So that gives us 3/4 x, and then plus, well, when you multiply 3/4 times 5/3, this 3 on top cancels with the 3 on bottom, leaving us with just 5/4. So 5/4. Okay, so I'm just going to rewrite that y as f inverse of x, and that's equal to 3/4 x plus 5/4. All right, in number 2, they give us a picture of g of x right here, and what they want us to do is they want us to graph this equation. Now, you could see here, this plus 2 within the parentheses tells us that we're shifting our graph 2 units to the left, and then this minus 1 at the end tells us we're shifting our graph 1 unit down. So you can just individually go through and shift whatever points you can. All right, so I guess I'll start with this point right here. If I were to shift this 2 units to the left and 1 unit down, we would wind up right here. I'm just with every point I can see. All right, if I were to take this point and shift it 2 units to the left and 1 unit down, I'm going to wind up right over here. All right, I'm going to do the same thing with this point right here, 2, -1. I'm going to shift it 2 to the left and 1 down. And as I keep going, let's see, my next point I can see is this one. So 2 to the left, 1 down. We can do it right here, 2 to the left, 1 down. And then it looks like after this, I'm going to be falling off the graph, so I'm not really going to be able to do any more of these. So I'm just going to connect what I have, and I will label that as g of x plus 2 minus 1. Put the y equals right in front. Number 3 talks about SAT scores being normally distributed with a mean of 500 and a standard deviation of 100. Now, in Part A, they want us to find the probability that a randomly selected SAT score is less than 450. So if you want to just think about visually what this would look like, well, if the mean score is 500, then the 450 is going to be to the left of the mean. So we're really looking for what percentages of scores are less than 450. So to the left of 450 on the normal distribution curve. All right, so first thing we have to find is the z-score that goes along with this. So if we do the value minus the mean divided by the standard deviation, that's going to give us -0.5. So if you want to do this in your calculator, you would just do normal CDF. And since we're looking for everything under 450, well, the 450 is a half a standard deviation below the mean. So we're looking for everything that's to the left of it. So our lower bound is going to be a really, really small number. I usually use -9999. And our upper bound here is going to be this -0.5. So we'll write the lower bound is a very small number, and the upper bound is -0.5. And when you do that, they want you to round your answer to the nearest thousandth, so I got 0.309. Okay, now for Part B, they want you to find the probability that the score is between 400 and 650. So our mean is 500, so 400 is going to be to the left of it, and 650 will be to the right of it. All right, so now we need to find a z-score that's associated with each of these. So if we want to find the z-score associated with 400, we'll do 400 minus the mean and divide that by the standard deviation to give us -1. And if we want to find the z-score associated with 650, we'll take 650 and subtract the mean and divide that by 100. Now, if you notice, I mean, these numbers that we're getting for our standard deviations, those are on your normal distribution curve. So if you didn't want to do this through z-scores and you didn't want to do this, using the normal CDF in the calculator, you can use your general old normal distribution curve. Okay, but here I'm just going to continue on doing it in the calculator. If we're looking for the percentage of scores that are between these two values, well, my lower bound is going to be -1 and my upper bound is going to be positive 1.5. So when we do normal CDF in our calculator, you can plug in -1 for the lower bound and 1.5 for the upper bound. And you do wind up getting to the nearest thousandth 0.775. Okay, so number 4 tells us we have a whole bunch of gumballs, and they want us to determine the probability of choosing 2 blue and 1 red. Now here we're using combinations because the order doesn't matter. We're just picking a group of 3 gumballs. So probability tells us we're going to need a fraction. On the top of this fraction, we're going to write out the number of ways we can choose 2 blue and 1 red. Okay, well, we have 16 blue to choose from, and we want to choose 2. So we could write that as 16 C2. The word and tells us to multiply in probability. And then from the 22 reds, we want to choose one of them. So 22 C1. Now in the denominator of our fraction, it's going to be the total number of gumballs we have to choose from. So if you add all these up, we have 58 gumballs. So we have 58 gumballs to choose from. And out of those, we want to choose a total of 3. So this is how we would set up our problem. Now, you could just plug this right into the calculator, and when you do, I mean, if you want to do the numerator first and then the denominator, this is what you'll wind up with. But you can leave it like that. Probability, you do not have to simplify. But if you do decide to simplify, you would wind up with 330 over 3,857. All right, number 5 gives us the formula for Newton's law of cooling, and it tells us that a pot of water is heated to a boil, which is 212 degrees Fahrenheit, and then placed on a counter to cool. The temperature in the room is 68 degrees Fahrenheit. All right, so before we go any further, the 212 would be the initial temperature of the object, so that's what would go in right here for T sub 0. And the T sub A is the temperature of the surroundings, which the surrounding room temperature is 68, so that's what's going to go in here and here. All right, so I'm just going to first put those in. So for T sub A, we said that's 68. And for T sub 0, we said that's going to be 212. Okay, so then for part A, it says the pot of water reaches a temperature of approximately 150 degrees after 6 minutes. So they first want us to find K to the nearest 10,000. Okay, so if the pot of water reaches a temperature of 150 degrees after 6 minutes, that means the lowercase t, which represents time, would be 6, and the T sub T would be the temperature after those 6 minutes. So this is where we could plug in the 150. So we'll have 150. And then E, I'm going to leave it as -K because that's what we're looking for, the K. And the time we said was 6 because 6 minutes has passed. Okay, so I'm going to rewrite this as 150 equals 68 plus, well, 212 minus 68 is 144. And I'm going to bring down the E to the -K times 6 is -6K. All right, so we're trying to get this E by itself on one side of the equation. So let's first get rid of the 68 and then the 144. And keep in mind, you cannot combine these two numbers because the 144 is attached to the E. All right, so if we subtract 68 from both sides of the equation, that leaves us with 82 equals 144 e to the -6k power. And then we're going to divide by the 144. Now, even though 82 over 144 simplifies, I'm going to leave it like that because we're going to plug it in our calculator anyway, so it's just kind of wasting a step to take the time to simplify it. All right, so this is what we're left with. Now, to get rid of an e, we need to put an ln in front of both sides of the equation. So when we do that, the ln of e leaves us with just negative 6k. So that's going to leave us with negative 6k. And I'm going to just bring the left-hand side down as ln of 82 over 144 for now. And then our last step to get k by itself is just to divide both sides by negative 6. And when you do, they ask you to round k to the nearest 10,000th. So I got 0.0938. Now, we're not done with letter A yet because letter A also says to write an equation to determine the temperature of the pot of water after t minutes. So they want us to leave it as t of t. They want us to leave it in terms of time. So we can rewrite that as t of t equals, well, we're still going to have the 68 plus 212 minus 68. Now, this time, we know the k, so we're going to write e to the negative, and let's plug in k, 0.0938, and that's going to be times t. So this would be the answer for letter A. And if you prefer, you can actually rewrite this. You can combine. You could say, well, 212 minus 68 is 144. So if you prefer to write it like this, which I actually like to do because then if you have to answer any other questions about it, it's just a simpler formula to use. But either one of these would be fine for letter A. Okay, now part B says determine how long to the nearest hundredth of a minute it will take for the pot of water to reach 100 degrees Fahrenheit. All right, so if we want the pot of water to reach 100 degrees Fahrenheit, we're going to replace this ending temperature with 100. And then I'm just going to bring everything else down. Because what we're solving for here is we're solving for little t. We're solving for the time it takes. Okay, we're going to solve this pretty much the same way we did, this equation over here in part A. I'm going to first subtract 68 from both sides, leaving me with 32 equals 144 times e to the negative 0.0938 t power. And then I'm going to divide by 144 to get the e by itself. So again, even though this fraction simplifies, I'm just going to leave it. It doesn't matter if I simplify it or not. Okay, and then to get rid of our e, we need to put an ln in front of both sides of the equation. So these are going to cancel, leaving us with ln of 32 over 144 equals negative 0.0938 times t. And then just to get the t by itself, just divide by that decimal that's in front of the t. And you can do this right here in your calculator. And when you do, they want you to round your answer to the nearest hundredth of a minute. So you get 16.03 minutes.